kinetic energy term. I'm writing second order. Plus 1/2 integration del phi 1 square rho 0 RT plus integration V external 1 rho 1 RT. In fact, this I can write, since I'm writing F, so I can write this as F T plus V plus all that. Alright? Plus the last one, d phi 1 dt rho 1 RT integration over R and time magnitude. Just by inspection, I have written the second order term. Okay? This minimized will give you the answer. So what one can do is choose a form for rho 1 and phi 1 in some terms of some parameters. Minimize this and you get E2. E2 is related to alpha omega. Scan it and you get the answer. So for example, if I take a sphere, metallic sphere, and since we are talking about quantum mechanical small systems, metallic cluster, sphere, gallium sphere. The density is all sum rho naught. R is going to be sum rho naught 1 plus something. I mean, this is going to be like this. Some form is chosen. Okay, I have a rho naught. And if I apply the electric field, E raised to minus or E cosine of omega t, the rho 1 R you can show is going to be of the form some function of R which I am going to parameterize cosine theta cos omega t. I'm just giving you a way of doing things, alright? And which I can write as sum A R raised to I. For spherical systems, you can do this. Then, if I look at phi 1, I know that d rho dt is equal to minus divergence of grad phi rho 0. Right? We saw that. This is a continuity equation. Right? This is continuity equation. If I choose this form of rho 1, grad of phi is d rho dt, right? So d rho dt is going to be sine omega t. And rho has cosine theta, so this should have a sine theta. So you can choose phi 1 to be of the form, another function, right? Summation vi r raised to I, choose sine theta and sine omega t. Plug it in, minimize with respect to A and B, you get E2. Okay? And E2, whatever you calculate, is equal to minus 1/2 alpha omega E applied square. Electric field square is the E cosine. That's right, it's easy. So you can calculate alpha omega, scan it, wherever alpha omega hits maximum, you've got your excitation frequency. Okay, so I'm just giving you a scheme of how to do things in TDDFT. Also, it's as simple as doing a stationary state, just more norms are there. So, calculate E2 omega by minimizing the expression for E2 with respect to AI and BI at omega equals omega resonance E2 omega to infinity. So that's how you can calculate the resonance frequency using TDDFT, Thomas Fermi approximation. Or higher order. I mean, you can write this F, I can include Thomas Fermi, I can include Thomas Fermi plus more terms, and so on. Any questions? If you do your orbital free DFT, whatever orbital free functions you make, this is one way of checking answers also. Apply them here, because you will be approximating T. Okay? Okay. So this is as far as the Thomas Fermi and all that is concerned. By the way, there was a universal curve of photon absorption cross section of atoms calculated through blocks here. And this was done by Wiener, and this is a review of one of the page. We'll continue doing first order response, and now apply first order response theory to Kohn-Sham system. I just want to remind you, when you do Kohn-Sham, Kohn-Sham, you have these occupied orbitals, right? And then you can also calculate the vacant orbitals. Then any of this epsilon j minus epsilon I is not equal to excitation energy. Why? Because these epsilons have no meaning. In Kohn-Sham theory, only the uppermost has a meaning of removal energy, but these virtual orbitals have no meaning. They just you can calculate them, but meaningless. The only meaning is there in these orbitals, right? And from that, so the question is, can I relate this gap to excitation energy? That's the question we're asking. Can we relate, say, omega Ji to excitation? And the related question is, what is the correction to omega Ji? So this is where the theory by Peter Sitka, Grossman and Gross comes in, theory by Mark Sila comes in. So the idea is that in a system, alpha beta polarizability, which is equal to summation f j over omega square minus omega j square, where fj is the omega j, psi, dipole moment operator, psi all square is the oscillator strength, omega j in the acceleration. This is a true system. Cone-Sham system, this is not going to happen. Right? So what I have to do is calculate alpha omega using Cone-Sham, equate the two and somehow try to pull omega j out. Is the idea here? This is psi here.